Hello friends, welcome to online lecture series. Today we will see another application of differential equation. Simple electric circuit. In that we will see RC circuit or RC series circuit. So let's start today's lecture. In last lecture, we already learned what is meant by the RL circuit and how much current is flowing through the RL circuit. Today, we will just replace the value of your inductance by capacitor. So, the circuit becomes RC. R indicates resistance, C indicates the capacitor. When the resistance and capacitor are connected in a series, and some voltage is applied to the given circuit, then the current flowing through this circuit we have to calculate. To find the current flowing through the given circuit, we should know the voltage across resistance as well as voltage across capacitor. The resistance and the capacitors are connected with a battery. That battery is denoted by the function E of t. And these three particular components are connected in a series. And the I is the current which is flowing through the given circuit. By the Kirchhoff voltage law, the sum of the voltage across the circuit is equal to the applied So with the help of we can find the voltage across capacitor. So we know that voltage across resistor is V suffix R, voltage across capacitor is V suffix C, and E is the applied voltage or applied EMF in the given circuit. So the voltage across distance is equal to times R, and the voltage across our conductance, that is a capacitor, is Q upon C. The charge upon the value of your capacitor just gives the voltage across the capacitor, and E is the applied EMF. We know that the value of your current in terms of charge, the rate of change of charge with respect to time is nothing but the current flowing through the given circuit. So the differential equation becomes, that is R times dq upon dt. It is the value of your I plus Q upon C is equal to the applied EMF E. This is the differentiable equation in Q. So we have to just convert into standard linear differential equation. So we can divide the entire differential equation by R. So after dividing the differentiable equation by R, we get dq upon dt 1 upon RC Q is equal to E upon R. The differentiable equation in charge, that is in current. So comparing this differentiable equation with standard form, the value of your P is 1 upon RC and the value of your Q or the right hand side is your E upon R. So we get the two values of the differential equation in which the value of your P is equal to 1 upon RC and value of your Q, that is the right hand side, is E upon R. We know that the integrating factor of the differentiable equation in Y is nothing but E raised to integration p times dx. Here time is my the variable or time is my the parameter. So we said that the integrating factor of this circuit is integration of your p with respect to t is a power of exponential function. Then replacing the value of your p, we get e whose power is integration 1 upon rc dt. And we know that the integration of your dt is t. So integrating factor of this differentiable equation is e whose index is t upon rc. And the general solution of this circuit means we have to find the charge across this circuit by the general solution is given by that is q into integrating factor is equal to right hand side into integrating factor dt plus k. Then putting the value of your integrating factor, that is a q e raised to t upon rc is equal to e upon r. Again integrating factor value is e whose index is t upon rc dt plus k. So e upon r is my constant. We are taking outside your integration and taking the integration of your exponential function. The integration of your exponential function is e raised to a. X is nothing but integration of your e raised to x is nothing but e raised to x upon a. We are using that formula, so we get the solution of this particular term. This r and this r get cancelled. So we get q e raised to t upon rc is equal to ec e raised to t upon rc plus k. To find the value of your constant of integration, we have to use the initial condition. So initial condition, before that we are multiplying this differential equation solution by e raised to minus t upon rc. Multiplying just this q into e raised to t upon rc multiplied by e raised to minus t upon rc becomes 1. Again the ec whose coefficient is e raised to t upon rc is multiplied by e raised to minus t upon rc get cancelled. So we get the value of your q. And then to find the value of your constant of integration, we have to use the initial condition. Then with the help of initial condition, we can find the value for q. So q at t equal to 0, my q is 0. So the equation becomes q equal to 0 and this t equal to 0 means the exponential function's index becomes 0. And we know that e raised to 0 is 1. So the value of your k is this is 1, and we shifted this e raised to ec to right hand side. The value of your k is minus ec. We have to put the value of your this k in this equation. So we get the value of q. The value of e is nothing but your minus times ec. We are replacing here. In the next step, we can take ec common from both the terms. Then we get one minus this. After taking ec common, this is the charge at any time t. At any time t. In this way, we can find the charge. We know that the rate of change of charge with respect to time is nothing but the current. So we are differentiating this equation with respect to. We have to just differentiate this equation. Differentiating with respect to t. This equation. So we get dq upon dt and derivative of your EC plus K times e raised to minus T upon RC. After differentiating, EC is my constant, its value is become 0. We get the current which is flowing through my given circuit. In this way, we can find the value of your charge or the value of your current flowing through the given circuit. So, in this way, we can calculate either charge or current. So, let's see an example to understand our concept. Here, an EMF 200 E times e raised to minus 5t is applied to a series circuit consisting of 200 ohm resistor and 0.01 farad capacitor. Find the charge and the current at any time, assuming that there is no initial charge and the capacitor. So we have to find the current and the charge which is flowing through the given circuit. And here the components are in this particular circuit is nothing but the capacitor and the resistor. The capacitor and the resistors are connected in the series, means we get a RC circuit. So according to Kirchhoff voltage law, we can find the value differential equation of the circuit. Circuit consisting of resistor and the capacitor and the battery. So according to the Kirchhoff voltage law, we can define the differential equation. The differentiable equations is IR is the voltage across resistance, Q upon C voltage across capacitor, and E is the applied EMF. So again, replacing the value for I in terms of charge, we know that the value for I is nothing but dq upon dt. We have to replace the value for I in this differential equation. We got R dq upon dt plus Q upon C is equal to E. Dividing entire differential equation by R, we get dq upon dt plus Q upon RC is equal to ER. Then we have to put the value of your RC and the applied EMF in the given circuit. So putting the value of your E and Q upon 20 times 0.01 is equal to 200 e raised to minus 5t upon 20. After simplifying this, 1 upon 20 times 0.01, it becomes 5. And the right hand side 200 upon 20 becomes 10. So the differential equation in which the value for P is 5 and the value for Q is 10 times e raised to minus 5t. So the integrating factor of this differential equation is integration of 5 times t, whose integration 5 is my constant. Again, the integration of your dt is t, means integration of your this particular differential equations integrating factor is e raised to 5t. The general solution is given by q times integrating factor is equal to right hand side into integrating factor dt plus k. Putting the value for integrating factor is e raised to 5. So putting the value for integrating factor, 10 is constant, e raised to minus 5t, e raised to 5t becomes the index addition is minus 5t plus 5t becomes 0, e raised to 0 is my 1. So we got the constant inside the integration. So q e raised to 5t is equal to 10 times dt plus k. 10 is constant, we have to choose as a constant which is outside the integration. So we got q e raised to 5t is equal to 10 and integration of your dt is t plus k. And initially the charge in the given circuit is 0. So we are putting the value of your t is equal to 0 and at the same time your q becomes 0. So we have to find the constant of integration, just replacing the value of your t is equal to 0 and q equal to 0. So we got k equal to 0 in this equation. So the charge which is flowing through the circuit is q times e raised to 5t is equal to 10. And the equation of your q becomes q is equal to 10 times t e raised to 5t. Charge at n. This is the value of your charge at any time t. So we required current. So differentiating this q with respect to t, And the right hand side containing two functions of t means we have to differentiate the given right hand side as a u into v rule. So we have to differentiate the right hand side as a u into v rule. So we have to differentiate this right hand side by u into v rule. The first 10t remains constant. We have to differentiate e raised to minus 5t. Its derivative is minus 5 times e raised to minus 5t. And derivative of t is 1. So we got this. After making the array, 10 becomes minus 50. And e raised to minus 5 to take as a common. So we get the value for I is equal to e raised to minus 5t in bracket 5t plus 1. In this way, we can find the charge as well as the current which is flowing through the given circuit. So in this way, we can find the charge and current in the given circuit. We will see the next topic on next lecture. Thank you.